This is WOCA, Ocala, Gainesville, The Villages, 1370 AM, 96.3 FM, The Source.
All right, 25 minutes before 10 o'clock. Thank you for tuning in. Not too far away from here at the University of Florida, there is a planetarium. If you didn't know that already, then you probably said, I didn't know that. And if you ever go to that planetarium, they put on some amazing presentations. It's small. Have you ever gone to this planetarium?
I have not, but you make me want to.
Oh my gosh, they put on such great programs. The guy who narrates it, I don't know if it's always the same guy, but we've gone twice, and it was the same guy both times Robin and I went. He's a professor at the university. Anyway, he knows his stuff when it comes to outer space, and it's just so fascinating. And a planetarium is able to show you things in outer space in such a cool way. It's just
you don't really see it otherwise. I mean, you look up in the night sky, it's not the same as a planetarium.
I know, you don't really. And did you ever live in a place where there wasn't many lights? Like,
yes.
I used to live in Rainbow Lakes Estates.
Yes.
You can see a lot more.
Yes, you can.
It's amazing how much we can't see.
How big the sky is.
Yeah, it's really amazing. Dr. Amy A. Simon is on the phone. She is the senior scientist for planetary atmospheres research in the Solar System Exploration Division at the NASA Goddard Space Flight Center. How cool is that? She's been involved in multiple robotic flight missions and future mission concept development, and the co-investigator of the Cassini Composite Infrared Spectrometer. I'm glad I'm reading that because I don't even know what I just said. We're talking about space, Mars, Saturn, the Hubble telescope's portraits of the planets, and more. Dr. Simon, what an honor to have you on our show. Good morning, Doctor.
Good morning. Thanks for having me.
Oh my gosh, you have such an exciting job.
Yeah, well, it sounds impressive when you describe it like that, doesn't it?
At Thanksgiving, does everybody talk to you? Like nobody would talk to me. What do you do? Talk on a microphone? Yeah, that's about it. I mean, you look at things that the rest of us just only can imagine, right?
Yeah, I get to see some pretty cool things. I get to use the Hubble Space Telescope quite a lot, and the images we get from there are just spectacular. It really is mind-blowing, even to me.
Can you aim it at the landing site on the moon? Are we able to do that?
We can't actually target the moon very easily. It's just a little bit too close. Hubble does better when the object isn't moving or when it's farther away. So Mars is the closest we can usually observe.
How far?
We have to sneak up if we try to get the moon.
How far is the Hubble actually above us?
The Hubble is in Earth orbit, so it's not that far. Eventually, it'll come down out of orbit, as a matter of fact. But it's still above the atmosphere enough that we can get those clear images of all the planets.
So if it falls like near me, can I have it?
I think it's going to be little pieces.
I think this is really, really marvelous. We were told that we're going to be able to view Mars and Saturn this weekend.
Absolutely. If you go out and look at the night sky, any night over the next bunch of weeks, actually, you can see Mars very clearly. It'll be the bright red jewel in the sky, and Saturn is off to its right. It'll be more of a pale yellow. So tonight is the best time to go look at Mars because it's at opposition. And that just means it's on the opposite side of the Earth from the sun. So that's the closest point that we get to it in its orbit. So it's the biggest and brightest that we'll see over the next 2 years.
Is the rover that got caught in the dust storm gone? I mean, was it buried by that dust?
So we have two rovers, actually. We have Opportunity, which is solar-powered, and because of the dust storm, it had to be shut down because it wasn't going to get sunlight. And we have Curiosity, which is nuclear-powered. So that one's still operating, and it's sending back data. It sends some images that are kind of interesting to see through that, dusty haze.
Oh, really?
But we're hoping once the storm passes, sometimes they actually scour off the solar panels and make it better. So we're waiting to see if we hear back from Opportunity, but it's been up there for a long time. So
are they near each other, the two rovers?
No, they're not that close to each other.
Okay, I thought maybe one could help the other, like tow it,
jumpstart it,
like tow it out, yeah, give it a jump start. Yeah, so we can see Mars with our naked eye or with binoculars tonight, right?
Absolutely.
So, and what are we going to see? I mean, we're looking for a bright light in the sky. Or are we actually going to be able to make out like a circle? I mean, if we're just looking up.
So it's close enough that, it'll be a bright red, almost star. It won't be twinkling, but it'll be a little bit bigger than a star would normally be. It'll almost look like a fuzzy red star, but very bright.
So if you're looking at the moon, is it going to be in that particular area, like off to the side of the moon?
Yeah, it'll actually be quite close. It'll be a little bit below it and to the right, and then Saturn will be farther to the right. So if you look around, say after dark, say around midnight, and look due south, you should spot the moon, and you'll see Mars and Saturn.
Wow. So where are you? Where do you live, or where do you work?
I'm up in Maryland, actually, in the Mid-Atlantic.
Oh, wow. And what's your day like? I mean, you go to work and you look at pictures from outer space?
I do, actually. I spend most of my day in front of a computer, and I analyze a lot of Hubble images, but also data from other missions.
Wow.
So do you deal with asteroids at all?
I do, actually.
I know where this is going.
With the,
Go ahead, you take it.
OSIRIS-REx.
Well,
OSIRIS-REx is an asteroid sample return mission,
Okay,
and I'm involved with that.
There's a story that's in the headlines today that we've been sharing with our listeners. I believe it's China that wants to kind of reach up and grab an asteroid and bring it down to Earth for all of its metal content.
It's a pretty expensive way to get your metal.
Well, we have tariffs on aluminum now. So.
Yeah, well, there's that.
I mean, is that even realistic?
There's a lot of, maybe a tiny one. We're doing the OSIRIS mission for scientific reasons, and we're going to pick up about 2 kilograms, about 4 pounds of rocks. But that's to study their composition and so on. Doing actual asteroid mining is a lot more complicated, and certainly to bring a big one back, I don't think we could technologically do. So it would have to be tiny in the first place.
Asteroid mining. That's amazing.
Do you know what I always wonder about? When you hear a story that says we have found a planet, scientists have found a planet that is just like Earth, and it's like a gazillion light years from here. We can see that, but yet we can't see Mars. We have to send up a rover.
Well, we don't know that they're fully Earth-like. What we do when we're doing that is we're looking at planets around the other stars, and we can't directly image them yet. So we're looking at their effect on the star, the fact they cross in front and give us little eclipses, things like that. And they look at the temperature and how far away it is from its star and can say it's Earth-like. But we've never looked at one directly.
Well, when the Hubble is aimed at the different planets, have you found anything unexpected within that range?
When we look at our own planets, every time we look, they're different, which is always kind of interesting. We never know what we're going to see at some level. So we've been watching the outer planets in particular. We've been watching Jupiter, and it has this great red spot you've probably heard of, and it's been shrinking over the last couple decades. But when we looked at Neptune a couple of years ago, it suddenly had a big dark spot too, which we weren't expecting. And that's been slowly diminishing, going away. We're using that sort of studies to learn about the weather and understand weather even here on Earth by having a different set of conditions to look at weather. So we're using the outer planets as laboratories, which is kind of fun.
So, Dr. Simon, let me ask...
every time we look.
Let me ask you this: as a 6th or 7th grader, way back when, did you make a model of the universe with all the planets, and that's when you decided you wanted to do what you're doing?
I had my styrofoam solar system, yeah, but I think I was inspired by the space shuttle program by Sally Ride, and this idea that eventually we would walk on Mars. That's what I was going to do.
Yeah, but you don't want to go. It's so far away. Everybody's going to miss you. Don't do that.
And it's cold.
Yeah. Elton John said so. At least right on top. When I was a kid in school, I remember the teacher showing us spectrums of different stars, and I want to ask you something about that, because some of the spectrums of light had blank spaces, and I remember the teacher saying that light, that as we know it, has wavelengths that we can't see. But our own sun, of course, we can see every color in the light from our own sun. So when the Hubble telescope looks at things that have colors or frequencies we can't see, do you guys have a way of decoding that somehow so you can see it?
Yeah, we do actually. So a spectrum, even from our sun, has little black spots, as you put it. It's absorption lines. It's like a fingerprint that tells you what composition of the star is. When we look at a planet, we're looking at the reflected sunlight, but some of those wavelengths will drop out from the composition of the planet too. And what we can do is fill that in to figure out what the composition is. But if you have something like Hubble, it can look beyond where your eye can see. So we can look in the ultraviolet, or we can look in the infrared that your eye can't see. And we use, our cameras have detectors on them that basically take any wavelength, and it ends up being black and white. And so when it comes back to Earth, it's just a black and white image, but it's at a wavelength your eye wouldn't normally see. So we can learn a lot that way.
Wow. And so and that's how you can tell, for example, what a planet is made out of or a star is made of. And how does that information get you, once you figure it out? I don't even know what to ask here, but how do you, like, let's say copper. I'm just going to use something I know. Let's say you say, okay, there's a lot of copper on Saturn. What does that do for us? Does it give us information regarding flying there one day or mining it or something?
Sure. If we saw copper, yeah, we'd probably want to go mine it. But what we actually do with this information of what it's made of is we can learn how the solar system formed. There's a pattern across the solar system of which elements should be in each planet. And if it's not what we find, then that tells us the planet probably moved or it didn't form when we thought it formed. And all of this is key to understanding how our own planet came to be at all.
And is that why those dark spots that are being looked at and discovered are kind of unnerving?
It's not unnerving. I mean, we expect this. Like I said, we use this almost like fingerprints. This is our forensic science. We're trying to figure out things from the past by looking at what's there now. And so these fingerprints just give us little clues. And what we have to do as scientists is piece together all those little clues because we don't get them all at once, and then try to figure out the whole mystery of what's going on.
Well, at some point, Hubble is not going to be around anymore. I would think it's almost 30 years old. So what's the replacement?
Mm-hmm.
What are you going to send up next?
Sure. So Hubble's at its kind of peak productivity right now, believe it or not, even given its age. It's doing fabulous. Everything's working well. So we expect it to keep going into the 2020s. And beyond, and eventually it will start to fall down into the atmosphere. We're looking at the 2030s, 2040s before that happens.
Oh, wow.
In the meantime, we're looking at the James Webb Telescope, which will be complementary to Hubble. So instead of looking at visible and ultraviolet light, it'll look at infrared light. But that's the next big mission that would go up.
Have you ever had an amateur astronomer, a layperson or whatever, looking at the pictures from Hubble and noticing something that you guys haven't not noticed?
Oh, yeah, absolutely.
Really?
They do two things for us. They look at the sky, actually, with their small telescopes all the time. And sometimes they'll tell us, hey, there's something going on. You guys should go look at it. And if we can, we follow up. And we have discovered things that way. But also, I've worked with a bunch of the amateur groups, and sometimes we just have more data than we have time to analyze, and they'll sit and go through it as well. So we have big citizen science programs, for example, with the NASA Juno mission at Jupiter, but also they've worked with me on Hubble, and they even get included on our scientific papers.
Can we actually see the Hubble? Like is it in a stationary spot, or does it, what do they call it, geostation? What do you call it when it stays in one spot? Like the space station, every once in a while you can,
Mm-hmm.
Yeah, can we see the Hubble?
Not usually. Hubble is in low Earth orbit, so it's a little bit lower than the space station, but also it's in a 90-minute orbit, so it's going around the Earth pretty darn fast. so it's hard to spot.
So if I see a little tiny light just going across the sky, it could be the Hubble.
It could be. I'm sure they have trackers out there. Tell you where to find it.
I know I have gone to the NASA.gov site, and then you have on that site where you can see the space station come across the dates and times that is visible with the naked eye, which I find real fascinating.
Yeah, I haven't seen a similar one for Hubble, but Hubble's also a lot smaller than the space station.
So we can go to the website and we can see the images we're talking about?
Absolutely. At nasa.gov/Hubble, we have all the images that Hubble takes are up.
All right, I'm gonna go to it. We have a phone call coming in. You ready for a phone call? From our listener. Our listener might be an amateur astronomer. Good morning. Thank you for calling. You're on the air.
Good morning. I'm calling about the satellites that are aimed at the sun, and they give you the GOES reading. And I also noticed that from my weather app that I have the intensity of the sun, and it's saying it's extremely high intensity. Now, I understand the sun operates in circles like that, and I'm wondering if you could predict maybe a time where the sun will not be radiating the Earth as much as it is now. And if you can think of anything else we could be interested in, I'm very much interested in how this is affecting our Earth. I think it's more than, this is the actual cause of global warming. I'll hang up and listen. Thank you.
Okay. Doctor?
So we do have a bunch of solar observing satellites. The Intensity app that you get on your phone is just giving you the cloud cover and the season. So, of course, the sun is more intense right now in the summer for us in the northern hemisphere. But we do have these probes that monitor the sun, and they're mostly looking for solar activity. The big concern we have tend to be solar flares, and those are high-energy events. They affect your satellite systems, your GPS, for example, and also all of our spacecraft that are operating throughout the solar system. So we like to keep a close eye on those sorts of things. The other thing we have is what's called the solar cycle. It's an 11-year cycle, and that is when it goes through periods of more intense activity or lower activity. And again, that would be the sort of thing that's going to affect how long Hubble lasts before it comes down. So those are the sorts of things that we monitor with our solar probes.
When we hear that something is like a million light years away, something like that.
Yeah, what does that mean?
Yeah, explain that first. That'll be first thing, yeah.
So we can look at light two different ways. You can look at it as if it were a particle, or you can look at it as wavelengths of light. And a light year is how long it would take, or how far, I should say, how far that particle could travel in a year. So it's moving at a really, really fast, millions of miles per hour, but it still, has to travel super far away. So when we talk about things being light years away, you can think about it as being millions and millions and millions of miles away.
So that the light we see, let's say it says 100,000 light years away, that light actually left that place 100,000 years ago.
That's right.
So it may not even be there anymore, right?
But is it time or is it distance?
It's both at the same time.
Okay.
It's because these are moving particles. So yeah, that's the exact right interpretation. If something were a million light years away, that photon left the sun a million years ago. And that's why you could be looking at stars, the light from stars that are gone. They're not there anymore.
Do you know what's amazing to me? I'm going to use like old maps just for a second, if you don't mind, just kind of regress. When you go to like an exhibit and it shows like an old map of Florida, let's say, before we had the ability to see it from the sky, it was amazing how the explorers figured out the shape. I mean, they got it a little bit wrong, but they were pretty close. When you look at the drawings that scientists did of our galaxy, right? Before we could literally see galaxies that are far away, I mean, they got it right. I remember in school seeing pictures of galaxies. How did we know? I mean, how did we know it was shaped like this when we never saw one until we had something like the Hubble?
Yeah, it's pretty impressive. There were some awfully smart people, I have to tell you. They also had the advantage of extremely dark skies. And I think they must have had just stellar eyesight. I don't know. But
Yeah.
they could go out with a really, a poor quality telescope compared to what you could buy now, and a dark sky, and sketch out even details on the planets, details of these nebula and these other galaxies with incredible, exquisite detail, and correct. And I'm not sure I could do that. So it's impressive.
Dr. Simon, how do you inspire young people today to pursue astronomy and the exploration of space as a career?
Well, I'd like to remind folks that, we're like you asked me before, I'm learning something new every day. I'm seeing new images. I'm seeing data sometimes before anybody else on the planet has even seen it. And that's an incredible feeling, that just the excitement of what we get to do. And, it's exploring. And it's kind of, in a lot of ways, not to be cliche, it's the final frontier. There's worlds, there's places we haven't explored yet. And here's your chance to be the person that discovers something new. So I think it's incredibly exciting, and I love when kids are interested in it.
It is cool. I mean, when you see pictures, every once in a while you'll see a video and it'll show the sky from the Hubble telescope, and then they'll take a pixel-sized area of that video and blow it up, and there's a whole bunch more there in that little tiny area, right?
Yeah.
Absolutely.
And what you're doing, you yourself are a role model, because you hear all of these news stories about how girls aren't into math, they're not into science. They have to have pink calculators to try to get them interested. But it's not true. I mean, everybody has their own career goal in mind, and it doesn't matter if you're a boy or a girl. NASA is very diverse.
Absolutely. We need all people of all kinds, all types, because that diversity of ideas is how we're going to learn new things. We need somebody who thinks differently than everybody else to find the answer to problems that we haven't been able to solve. So absolutely, everybody that's interested should pursue their dreams.
Did you see Hidden Figures? Did you see that movie?
Oh,
I did.
That was a good movie.
Oh, my God. You got to see it, Kevin. Yeah. I mean, it really showed two things, how women were treated and especially how black women were treated, right? At that time. So did you, when you see something like that and you realize the importance of math in order to do what you do, it's over my head. I have no clue how any of that works. But in that movie, it showed that in order to get the astronauts back, so we knew where they were and when they would be there, the math equation had to be dead on. And I'm guessing that's true for everything you do, right?
Yeah, it is. And we have the advantage of supercomputers and high-end calculators. Can you imagine doing all of that by hand and having to get it right?
Yeah. Did they really do it on big, blackboards at that time? Is that how they did it, or was that just for the movie?
Probably a bit for the movie, but, if somebody ran a calculation, you saw this if you watched Apollo 13, too, 5 other people also would check it.
Yeah.
So, does everybody get the same answer?
Wow. It's just amazing how now this is why when they say, what do I need to know this math for? Well, that's it right there. Yeah.
Exactly.
That and your
You never
checkbook.
know.
Yeah.
Some people are afraid that the private entities like Elon Musk is going to overshadow NASA. What is your opinion?
Oh, I'm not too concerned about that. I think what these private industry guys are doing is great, and I think it's complementary. In some ways, we develop some of the ideas and the technology sometimes, and we often pass it off anyway, so that we can focus on the next problem. So I don't see it as a problem. I think anything that gets us more access to space and more ability to explore is a good thing.
Is there anything that protects the things that we have from getting hit by little meteors and things like that, like the space station? How do they avoid being hit?
So when we're going to launch things, we have to think of everything we can before launch, especially for the satellites that you can't service or you can't send an astronaut out to go check the surface of, right? So we go through a crazy amount of testing where we take everything we're going to fly to extremes in temperature. We shake the heck out of it, and we actually do put layers of insulating blankets on them so it doesn't get too cold or too hot, and that usually has a layer in it to protect it from micrometeorites as well. So we do the best that we can, but inevitably, things get pretty beat up in space, even though it's pretty empty, particularly in Earth orbit.
So here's an odd question. Are those types of things insured? Is the Hubble telescope insured?
Oh, good question.
Yeah.
No.
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 So when it comes down, that's it.
All state.
That's it.
All state. We had a rock hit our telescope.
Can we reinstate Pluto as a planet? I was real disappointed when I heard him demoted to a dwarf planet.
Yeah, I like it as a planet myself. I actually knew Clyde Tombaugh, the discoverer. So.
Oh my, that must have been exciting.
So
It was, and he was fiery on the topic. I can tell you that. But we'll see. These definitions change from time to time. The planets themselves don't care what you call them.
No.
So that's a definition.
It seems like some of the moons, especially around Jupiter, perhaps are like planets, except they circle around another planet. Are they places we might be going for any purpose? Like, could they sustain life? What was the one that?
Yeah.
I think they said there was water, or they believe there's water on one of them, right?
Mm-hmm.
There's several of them actually. Europa, which is one of the big moons of Jupiter, we think has a subsurface ocean, and Enceladus, which is a very small moon on the edge of the rings of Saturn, also has water. It shoots water geysers into space. We can see them.
Oh my gosh!
And we think there's other areas too. So it's possible that, when we actually find life in the solar system besides Earth, it's going to be below the surface of Mars, of Enceladus, Europa, one of these other satellites, just because that's where the energy and the water are. So,
did you ever have?
Yeah, stay tuned.
There was a story that the rings around Saturn smelled like rotten eggs. How do we know that? Or is that just one of those things? Is that true?
She's laughing at you, Larry.
Yeah, well, when you're in the checkout line at the grocery store, those magazines have a lot to say.
Sure. Well, we have chemicals that we can detect in these planets, the rings, or in the atmospheres. We do detect methane. We can detect hydrogen sulfide. There's other polycyclic aromatic hydrocarbons, all sorts of things that would be smelly, sure. If you went and tried to sniff the rings, would they be smelly? Probably not.
You are fun and so smart. Oh, my gosh. Dr. Amy Simon, what an honor. Thank you so much. Leave us with something like a website. You said nasa.gov/Hubble. Is there anything else?
Absolutely, and follow us on social media. We put all of our big stories up on Twitter and Facebook and so on, so at NASA Hubble.
Well, on behalf of us Earth people, thank you. We have heard so many stories about things that we benefit from. I guess Velcro is one of them, that would not be part of our lives if it wasn't for the space program. So thank you on behalf of us to all of you scientists. Thank you, Doctor.
Thank you so much.
We'll be right back.
Broadcasting from the Paddock Mall Studios, this is WOCA, Ocala, Gainesville, The Villages, 1370 AM, 96.3 FM, The Source.
Fox News Radio, I'm Chris Foster. The economy growing at its fastest pace in 4 years, 4.1% in the second quarter of the year.
Trade played a big part of the second quarter number. Net exports added more than 1 percentage point to the 4.1% GDP growth. Some of that would have been buying by overseas trading partners of soybeans ahead of these tariffs that went into effect in the beginning of July.
Fox Business Network's Dagan McDowell, the number's nearly twice as strong as this year's first quarter. A lawyer says he has more women claiming they were paid to keep quiet about affairs with President Trump.
Michael Avenatti, a lawyer for adult entertainer Stormy Daniels,